In the first video, we saw how AI models run inside an Android application. And in episode 2, we actually integrated a pre-trained model and it worked in basically one line of code. But if you are anything like me, the first time, that one line felt like magic. You typed classify, you got an answer, and you had no idea what actually happened in between. So this episode has no new demonstration. Instead, we're going to build the mental model of TensorFlow Lite, what it actually is, and what's really going on under that one line. Get this thing right, and every other episode in this series is going to make a lot more sense to you. Here's exactly where we left off in episode 2. We loaded a model, we classify on an image, and we got back a label and a confidence score. And that's great. But notice how much it's hidden. You handle it an image, you got back a word. What happened in between? That in between is what TensorFlow Lite actually is. So for the rest of this video, every concept we cover is really just answering that one question. What happened between the input and the answer? So let's define it clearly. TensorFlow Lite is really two things. First, it's a file format, that .TFLite file. Think of it as a single, self-contained box that holds a trained model, small enough to ship right inside your applications. Second, it's a runtime, the engine that opens that box and runs the model on the device. And here is the single most important thing to understand. The thing that clears up 90% of the confusion for beginners. TensorFlow Lite does not train models. It only runs them. The learning already happened somewhere else on a big machine. TF Lite is purely about taking that finished model and running it fast on a phone. If that still feels abstract, here's the analogy I wish someone had given me. TensorFlow and PyTorch. The big frameworks, those are the kitchen. That's where the meal, the model gets cooked. It's heavy work. It needs powerful machines, lot of GPUs, lot of time, and you usually do it once. TensorFlow Lite is a microwave. It does not cook anything from scratch. It takes something already prepared and heats it up. Fast, cheap, on a tiny appliance over and over again. Your phone is the microwave. It's never going to be the kitchen. And it does not need to be. It just needs to run the finished model quickly. That's the whole division of labor. So why go all this trouble? Why not just run the full TensorFlow on the phone? 4 different reasons. First one, size. A full model can be gigabytes. A TF Lite model is often just a few megabytes, small enough to build right into your application. 2, speed. It runs directly on the device, so you are not sending data to the server and waiting for reply on every single prediction. Third, offline. Because there is no server, it works with no internet at all. On a plane, in a tunnel, in a basement, it just works. And fourth, privacy. That once big, the user's photos, their voice, their text, it never leaves the phone. That's a huge deal for trust and increasingly for the law. Small, fast, offline, private. That is the pitch. Okay, let's open up the box. What's actually inside that .TFLite file? 3 things. First, the graph. That's the list of the mathematical operations the model performs. Its structure, its recipe. Second, the weights. These are the millions of numbers the model learned during training. The graph is the recipe. The weights are the seasoning it figured out. And third, optionally metadata. This can include the labels, so the model knows output number 3 means cat. And for the text model, the vocabulary it uses to turn words into numbers. Here is the payoff. Remember in the episode 2 how classify just word when we handed it an image? That wasn't magic. The metadata, the labels, is baked right into the file. The model file itself knows how to prepare your input and label its output. Hold on to that because it explains the next concept too. If you remember one thing from this entire video, make this slide. Everything inside a model moves as something called a tensor. And a tensor sounds crazy, scary, but it isn't. A tensor is just a typed multidimensional array of numbers. A list of number, a grid of number, a cube of numbers. That's it. Here's the flow. You start with your data, an image, that gets turned into an input tensor, just numbers. An image becomes a grid of pixel values. A sentence becomes a list of token IDs. Those numbers go into the model, the math runs, and out comes an output tensor, more numbers. Then those output numbers get turned back into something you understand, like cat 93%. And this is the key realization. The model never actually sees your photo or your words. It only ever sees numbers going in and numbers coming out, turning out your data into numbers and numbers back into answers. That's the real work. And in the episode 2, we have already seen this thing when we were using classify function. So who's actually running these numbers? Two more terms and we're done. First, the interpreter. This is the object that loads your .tf file and runs a single inference. Numbers in, numbers out. When you called create from file with options in episode 2, an interpreter was quietly created for you. It is the engine. Second, delegates. A delegate decides which chip on the phone actually does the math. By default, it runs on the CPU that works on every device always. But you can hand it to a delegate to run on the GPU, which is often very much faster, or an API, which is Android's dedicated AI hardware on supported phone. Same exact model, same file, just pointed at a different chip. Now here is how everything you have learned fits together in practice. There are two doors in TensorFlow Lite, and they lead to the same runtime underneath. Door 1 is the high-level task library. That's what we used in episode 2. You can classify with your input and it hides all the tensor work, turning data into numbers and back again. It's the perfect for standard tasks like image or text classification. Door 2 is the low-level raw interpreter. Here you feed the tensors yourself. It's more work, but you get a full control and you can run any model of any shape, not just the neat ones that task library supports.